Appbase.io now supports functions, which provides you the ability to improve the search relevance or to improve the custom security logic. Here are some of the use cases where functions could come really handy. For example, if you want to promote some results, you want to improve the ranking of the results, you want to hide them, or you want to update the query based on some natural language processing before it actually hits your search server, then you can always implement a function. Now, why to use appbase.io functions? Appbase.io functions resides on the same infrastructure as of your search service, that is Elasticsearch. And thus it helps us in minimizing the overall latency that user will see when searching across your application. This is different than AWS Lambda because AWS Lambda can add the search latency, and you would not like to pay that cost, especially dealing with the search experience of your application. This search latency becomes really profound when you try to perform some heavy operations on your Lambda functions, or you are trying to access the database system. Also, appbase.io functions have access to the Elasticsearch instance. This means they can read-write the data at much higher rate than any third-party services that you would like to introduce. Now, how this actually works. So appbase.io uses OpenFS, an open source service, to run and deploy the functions in the language of your choice. And using appbase.io dashboard, you can always configure when you would like to invoke these functions. Now there are two ways you can host appbase.io and functions. One is using appbase.io clusters, where functions are supported out of the box for production 2, 3, and 4 plans. All you need to do is go ahead and create function, deploy function, and set triggers. With the self-hosted appbase.io, now you can access all the appbase.io functionalities along with the functions with the Elasticsearch, which is hosted on some another infrastructure like AWS or elastic.co. So in this video, we will specifically cover how you can use self-hosted appbase.io using Kubernetes orchestration. For that, we will go to our self-hosted example. In this example, we give a quick guide on how you can create a cluster on Google Cloud with Kubernetes enabled and deploy the Elasticsearch using ECK Kubernetes operator that elastic.co has developed. Alright, so let us go ahead and first of all create a Kubernetes cluster on G-Cloud. Alright, now that our cluster is created, let us go ahead and see how we can deploy Elasticsearch over here. So first of all, we need to get the custom resources required by the Elasticsearch KTS operator. So this is the command. I'll just go ahead and paste it. Now once the custom resources are available, we can actually go ahead and deploy the Elasticsearch. This is a sample configuration that we have where we are using Elasticsearch with 5 GB of storage and 2 GB of RAM. You can always update these values based on the resources that you have. Alright, once the Elasticsearch is created, we need to monitor till it gets up and running. So this is the command to monitor the process whether the Elasticsearch is up and running. kubectl get Elasticsearch. It says still it is applying some changes, so let's wait for a while and retry this. Alright, so seems like our Elasticsearch is up and running. Now let's see how we can configure the Arc. So for that, we will have to go to Arc dashboard, create a new instance. I'll just enter my email address. Once I verify my email address, it will actually send me an Arc instance ID which I can further use to configure the Arc deployment. Let's go ahead and see what are the next steps. So in the next step, we need to deploy Arc. So Arc is nothing but a name that we have given to an app-based.io services, and we have created this sample YAML file which deploys all the services required by the Arc for you. So it basically adds Nginx and the ingresses required by the Arc. Now at this moment, Arc might not be up and running because we haven't configured it with the Arc ID that we have received in the email. So let us go ahead and do that. Also, we might have to set few other environment variables like Elasticsearch cluster URL and username and password. These are the master username and password that we would like to use with our Arc services or app-based.io services. Also, in order to get the Elasticsearch URL, we will have to actually get the password that is used by the Elasticsearch because the default ECK comes with an expect security which has basic auth enabled in it. So this is the command to actually get the decoded secret of Elasticsearch, and this is our password for Elasticsearch. So our Elasticsearch URL will look something like this. The user is elastic : the password that we just saw on the terminal, and @elasticsearch-es-http:9200. Now this is the service that we are not actually exposing to the end user. We will be using inside our containers only. So now let us configure this environment variables. For that, I'll just copy and use an online editor. So we just need to update the Arc instance ID, which I have already received in an email. So I'll do that. Update the password for Elasticsearch URL. So we just need to copy it from our terminal. And that's all. Now we can paste this command and configure the app-based.io services. As you can see, it says deployment configured. We can verify by getting the pods. So kubectl get pods. As you can see, our Arc is running now. We can also verify it using the cluster IP address. So in order to get the IP address, we just need to run this command. It will give us the IP address that is exposed using ingress nginx. So it's a curl http, then the IP address -u admin, and as you can see, we are getting the same output as we get with the Elasticsearch endpoint. Now we highly recommend using this cluster with TLS certificate and your domain, so that it is easily accessible using the app-based.io dashboard. Otherwise, you might see some challenges over there. For example, if I just use this IP address and username as admin, then it might not log in directly, but you might have to allow the insecure content over here, which I have done for now. Alright, so app-based.io and Elasticsearch are configured. Now let's see how we can deploy functions. For that, I'll go to our documentation again, and I'll go to hosting section where we explain in depth on how to host app-based.io functions using OpenFS and Kubernetes. So there are some prerequisites. You need to have Kubernetes and a Helm chart installed on your machine. Helm chart allows you to easily deploy services for Kubernetes. And first of all, we need to add the namespaces for OpenFS. So we'll go ahead and add the namespaces. Next, we need to add an OpenFS repo using Helm command. So I'll do that. Alright, now this step is optional because we are not going to expose our OpenFS services to the end users, and we are not going to use it by load balancer. So we can actually ignore the basic auth as only the Arc services inside our container is going to use OpenFS. Now we can directly jump to how to deploy OpenFS. We'll be using again Helm command with these options where we are saying that the namespace is OpenFS, the namespace for functions is OpenFS-fn, and we are just setting the basic auth false because we don't want to deploy that. Alright, so let's go ahead and add that. Seems like OpenFS is installed. We just need to verify whether all the resources are deployed or not. So this is the command we can use. Alright, seems like all the services from OpenFS are now up and running. Great. So what is the next step now? Next step is to configure OpenFS with the app-based.io environment variables. So if you remember, we configured few environment variables in this YAML file. We just need to add this OpenFS gateway over there. So I'll go ahead and do that. Now this URL means like we are using the gateway service of OpenFS with the OpenFS namespace and this port number. If you have exposed your OpenFS service using load balancer, then you can actually use URL in this pattern, that is username, password, @IP address and :8080. But we highly recommend using OpenFS on the same infrastructure and not exposing it publicly. The another environment variable that you can configure is OpenFS Cube config. This will be really helpful when you are using the private registries for the functions. We will see that in our create function video how you can use the private registry. But when you are configuring a self-hosted app-based.io, you need to provide a path where your Kubernetes configurations are present so that we can create secrets for the private registry. Alright, so now that our environment variables are set, let's rerun this command so that they are applied as well. Alright, so it says that Arc is configured. Let's verify whether Arc is up and running or not. I'll do that using kubectl get pods. And as you can see, the Arc is up and running. It just restarted right now. Great, so now we can actually go ahead and see in our dashboard whether we get functions view or not. So here we go, and it says like we can start deploying functions. That is great. Alright, so in our next video we will see how actually we can create a function and deploy it and invoke those functions. Thank you.